Hello everyone, welcome back to the System Design series where we are discussing all the important concepts which are very important for your system design interviews. Today we will be discussing on notification system. We will understand everything about notification system, and finally we will end up designing a scalable notification system in this session. So let's get started with the basic understanding of notification system and why it is important in most of the software applications. Notification system used to notify users of the system about specific events. As an example, we can think of an e-commerce system where if we order something, as soon as we place the order, we get notifications in our devices. So notification system used to notify users about some important events. It is a very important sidecar system for most of the web applications. For example, if you are building some e-commerce system, you should rely on some notification system. That is the reason it is known as a sidecar system, because it gets attached with the primary system, and primary system relies on notification system in order to send any notification to any of its users. Nowadays, you cannot think of any web applications which does not have notification system. Hence, this is a very preferred question for any system design interview. There are a number of channels through which a system can send notification to its users. It can be push notification, SMS, or an email. There are other popular channels as well, because even we get notifications via WhatsApp nowadays. But in our discussion, let's concentrate on these three different channels for simplicity. As we know, to understand any system, you should ask few important questions to understand the actual requirement and the use case of your system. So let's understand the system before designing it. Remember, requirement analysis is a very important step in any software system, because through this you will be able to understand the actual use case of the system you are trying to design, and in turn it will help you to take important decisions while designing the system. Queries such as what type of notifications will be supported? Is it a real-time system we are trying to design? What triggers notifications? Can a user choose to unsubscribe? To understand the scale of your system, we can even ask how many notifications will be sent out each day. These are very important questions we have to clarify before designing the system. Let's assume for our design scope, we will be supporting push notifications, SMS, and email. We are trying to build a near real-time system, sometimes also called soft real-time. Let's assume our client will hit an API in order to trigger the notification. User can choose to unsubscribe themselves, and we will be assuming there will be 10 million notifications per day. Now we have realized the actual requirement of our system. Let's perform back of the envelope estimation to realize the scale of our system. As we know, our system will send out 10 million notifications per day. We can calculate the QPS, or queries per second. It will be 10 to the power 7 by 10 to the power 5. If you are not aware how I am converting 10 million per day to 10 to the power 7 by 10 to the power 5 notifications per second, please watch my back of the envelope estimation video present in this same playlist. So QPS will be 10 to the power 2 or 100 notifications per second. Usually we calculate peak QPS by doubling this value. As our peak QPS is coming as 200 notifications per second, we have to design a system such that it can handle 200 notifications per second with an ease. If we want to store all the notifications in our storage, let's calculate the storage requirement for our system. Let's assume every notification will take 1 KB storage space. Then, in order to store 10 million notifications per day, we need 10 GB of storage space. Again, if you are feeling lost how I am calculating back of the envelope estimation, you can watch my back of the envelope estimation video. With this back of the envelope estimation, now we know the estimated scale of our system. This will help us to take critical decisions while designing the notification system. Let's understand what are the APIs we have to design. We will have one post request, something like notification, and the request body will be consisting of the message we are trying to send to our user and the target users for this notification. We can use some array and pass user IDs. Response for our APIs can have 200 OK, 429 too many requests, or it can throw server error. There will be no other APIs for our system. As and when client wants to send a notification to a group of users, it will use our post API and send the intended message and the user list. Our system will send notifications to those users. Hope you have realized our requirement point number 3. Before we design our entire system, let's first understand how push, SMS and email notifications work. In case of push notification, notification producer prepares and sends a notification to either APNs. APN stands for Apple Push Notification Service, which can send the push notification to Apple devices, or producer can send notification to FCM, also known as Firebase Cloud Messaging, in order to send the push notification to any Android device. So now you know, in order to send push notification, we need either Apple Push Notification Service if we want to send the notification to iOS devices, or Firebase Cloud Messaging Service in order to send the notification to any Android devices. Both of these services needs device ID and tokens in order to send push notifications to the devices. For SMS, producer prepares the notification and send it to SMS service provider. There are a number of SMS service providers in the market, and those third-party providers send SMS to the devices. To send SMS, you need mobile numbers. Email notifications are also very common, where producer prepares an email and send it to some email service providers, and those third-party service providers can send emails to the users. For this, we need email ID. Hope you have realized how we can send notifications via different channels. Now, the natural question is, how can we get these device ID and tokens, mobile numbers and email IDs of our users? Let's understand that. We know notification system is a sidecar system. Hence, notification system will be always associated with the primary system. Let's assume notification system has a number of clients. One of them is an e-commerce system. So as soon as users register themselves to the e-commerce system, during the registration process, we can save all the contact details and the device IDs to a database. Though this flow is out of our notification system flow, but it is good to understand how we will be collecting device ID and tokens, mobile numbers, email IDs for each and every users. So now onwards, we will assume that we will have a database where we have user details as well as device details, which is accessible to our notification system. Now let's start with our actual notification system design. In notification system, our client will send a post request, which is notification, to our notification service. Our notification service will use the database in order to get the user details and the device details, and then send the notifications to the third-party service. A third-party service will send the notification to APNs, FCMs for push notifications, SMS service for sending SMS to the users, and email service to send the notification via email. And finally, it will reach to the user's electronic device. Let's go through the flow one more time. Let's assume our primary service is an e-commerce service which collects user details and device details during the registration process or sign up process. As and when users perform some activity in the e-commerce system, after performing the important activities, e-commerce system wants to send notifications to its users. What it will do? It will call our notification API, what we have designed during our API design phase. It will send the notification message and the list of users where our notification service has to send the notification. Our notification service uses the same DB in order to fetch the user details and the corresponding device details and prepare the notifications, send it to the third-party services. Now, third-party services will use APNs, FCMs, SMS service and email service in order to send the notification to the end user. We have few issues with this simple design. What if the third-party service is down for 5 minutes? So all the notifications what we are sending to the third-party service, as the third-party service is down temporarily, we will lose the notifications. In order to solve this problem, we can make this communication between notification service and the third-party service asynchronous by introducing some queues in between. Let's understand what will be the refined design. So we are getting notifications from our clients to our notification services. Notification service uses user details and device details from the database, prepares the individual notifications and send it to a queue instead of sending it directly to the third-party services. Now we can introduce few workers. Multiple workers will pick up individual notifications from the queue and send it to the third-party application. By using this design, we can avoid the loss of notifications when our third-party application is down temporarily. Remember, we need to send 200 notifications per second. So for each notifications, accessing the database will be an overhead. In order to enhance the performance, we can introduce cache in between. Our cache will store the user details and device details and quickly provide the information to the notification service. Hence, notification preparation process will be faster if we introduce cache. So, both in cache and the database will have user details and the device details. Our notification service first check if the information present in the cache. If it is present, then it's a cache hit and it will get the information quickly. If the information is not present in the cache, it will go to the database in order to fetch the data and then it will update the cache accordingly so that the subsequent requests for that same information will take lesser time. Now let's think about these workers. We can have different type of notifications in our queue and based on the notification channel, the processing could be different. That means in this design, the same worker will be used for all types of notifications. So during runtime, it has to understand that what kind of notification is it. Is it a push notification, SMS or email? And based on that, the processing could be different. In order to reduce the headache of each and every workers and to enhance the performance, we can split this queue into multiple queues, each having only one kind of notifications. So after getting notification request in our notification service, it will consult cache in order to get user details and corresponding device details. If there is a cache miss, it will check in the database to fetch the same details. Once it gets the user details and the device information. Based on the channel type, it can send the notifications to any one among these notification queues. Let's assume this queue is for push notifications. This queue will store only the SMS notifications, and this one is dedicated for email. And we will have smaller set of workers which will be proficient to pick up a single type of notifications and send it third party service. The benefit is our workers will be tightly coupled with the type of notifications we are trying to send, and obviously this will increase the performance of our system. Note that each and every workers will generate the notification content and send it to the third party service. That is the reason we can keep templates for each notifications so that our worker can quickly prepare the notification to be sent to the user. And as during our back of the envelope estimation, we did evaluate the storage requirement of our system, and we thought of storing or saving the notifications we are sending to the users. Our worker can log each and every notifications they are processing in order to adhere the requirement. Hence, we will have a detailed log containing all the notifications we have sent in a day. This will be important for our other services such as analytics. We can even introduce retry facility as we are using queues in order to store the notification request. Additionally, we can add analytics system to our notification system in order to perform some analytics operation. For this, we need some feedback from the third party services. They can help to understand if the notification is clicked by the user or not, the notifications are successfully sent to the user or not, and many other matrices for our analytics. And this final design will be scalable enough to handle the load we have estimated. Let's summarize the session now. In this session, we discussed how can we design a notification system. We realized notification system is a sidecar system of a primary system. Notification systems are important in all the web applications we can use in our daily lives. Hence, it is a favorite question for interviewer. In order to understand the system in details, we asked few critical questions. Once we have identified the use case of our system, what we are going to design, we performed back of the envelope estimation to understand the scale of the system. We also realized how push notification, SMS notification and email notification works individually. We designed the API needed for our notification system. We realized what will be the request body and what will be the response. We started with the initial design where we realized the flow where user registers or sign up to a primary system. We get user details and device details required for our notification service from that same database. And finally, notification service sends notifications via third-party services. Now, what if our third-party services are unavailable due to some reason temporarily? We will lose the notifications, what we cannot afford. Obviously, we need to have some asynchronous system. We made this synchronous design to asynchronous design by adding a queue in between. Hence, notification service will send the notifications to the queue. We will have a number of workers which will pick up the notifications from the queue in parallel and send it to the third party application. If the application is down for a fraction of seconds, our worker will wait till the third party app is up again. We realized why cache is important for our notification service, because during back of the envelope estimation we realized there can be 200 notifications per second. Hence, fetching information from the database for each notification will be a time consuming task. Hence, cache is important here. We also have realized these workers does the heavy lifting. Same worker will be used for all type of notifications. Hence, there will be considerable amount of logic in order to understand what kind of notification it is and prepare the notification based on the notification type. To reduce this overhead, we introduced separate queues for different type of notifications. In our case, as we are considering push, SMS and email notifications, we can have 3 different queues and smaller set of workers which will be proficient to process a specific type of notifications. There will be less logic or overhead involved. Workers can quickly prepare the notifications if we have templates in place. We thought of having templates in our database what workers can consult with. Workers also write the log for each and every notification it processes, so that we can use this log for our maintenance and analytics purpose. We can also introduce the retry mechanism in our workers, so that if one notification has been failed, we can retry it again. And finally, we can add an analytic system which can track few important matrices like the notification sent to the user has clicked on the notification. Those kind of information we can collect in our analytics system as a part of an OLAP storage, and we can perform a lot of analytics on top of it. Hope you have enjoyed this session. If you have learned something new, do not forget to like this video. I will be adding few more high level system design videos in this series. If you want to get notified, do not forget to subscribe my channel. Thanks a lot for your time.